Good afternoon. Welcome to this next of the IoT SBOM webinars, next session, where we'll be talking about the development of SBOMs on the basis of existing software, existing materials already, utilizing, in this case, a couple of tools, and where we as platform are starting to use also different types of different SBOM tools, and we wanted to share some of the experiences on that basis. My name is Ulrich Saltestachs. I'm the managing director of the association called ELSEC, and we're one of the IoT SBOM partners next to the University of Leuven and Flanders Meek, also based in Leuven. The three of us both in Leuven, Belgium. But that doesn't have to basically stop the fun, of course, because we are operating from within Flanders today from Antwerp, out of ENY offices, and specifically thinking about how our SBOM developments can also reach out to others within the European Union, and specifically to promote, of course, the concept of more security, more transparency in products and services, to get to a more cybersecurity world. So IoT SBOM is a project that we have started about a year ago with the support of the Flanders Flemish Commission, and in this case, really to support companies which are developing technologies, both software as well as hardware, and helping them in their developments of bill of materials, security and software bill of materials, with a slight more focus towards security in this space, because of course we are an association focused on digital security, calling ourselves Digital Security Catalyst. ELSEC has been around for more than 20 years now as a spin-off of the University of Leuven, and we do see that things like bill of materials can actually help also the security posture of companies, both in the buy side as well as in the produce side. So with the project called IoT SBOM, which stands in essence for Industrial IoT Security Bill of Materials, we aim to support cybersecurity innovations by improving the maturity of connected companies, basically companies that are using technologies, IoT technologies, software, which we help, in this case, understanding what SBOMs are for them in order to start also consuming what the SBOMs are. And the consummation of an SBOM means, in this case, that you can be any type of company, which is basically, in this case, looking for technologies, and you will be able to use an SBOM to get a better understanding and a better perspective of, in this case, the vulnerabilities caused by the software that you're buying, both in terms of the software on hardware as well as the software in terms of services or software technologies. We also use the same concept to support existing technology companies which are developing their own technologies, both software and hardware, obviously, again, and helping those in creating their SBOMs, in developing what an SBOM should really look like, how to get from core security developments and application development into the development of, in this case, a bill of materials, software or security bill of materials. And this is mainly meant to support the transparency and also the security of their products, and also to help them in the future of the management of their security and products. We also definitely see that for those product and technology development companies, an SBOM can serve and can help providing some materials for regulatory perspectives. There's a Cyber Resilience Act in Europe, which is basically calling for more transparency and more documentation on the security of the different products. Or in the US, for that matter, for those companies who are exporting to the US, where in some cases SBOMs are basically a requirement if you, for instance, want to sell to government agencies or the government overall. So that is the reason mainly why we also are focused on supporting companies in the developments of SBOMs. In the world today, one of the challenges is that there is basically a challenge in understanding what the different softwares are all about and how they run. Basically, we're all buying and acquiring all different types of technologies, and most of those technologies are obviously using software. The world runs on software. And more importantly, in that sense, is that quite a lot of those softwares are being developed on the basis of some form of open source components, include some open source elements. So therefore, it could be useful to at least understand what those components are, and even more useful to understand if there's any vulnerabilities in those open source applications or softwares. As you can see, I mean, there is quite a lot of challenge because there are simply more developers than there are security professionals. So therefore, we need to build out a system that allows developers in this case to faster also provide security mechanisms in their developments. And so this is why quite some time ago, more than a decade ago, the concept of a software and security bill of materials was conceived. And through the means of the Cybersecurity Information and Information Security Agency in the US, the development of SBOMs is heavily promoted and supported in the industry. Now, what is an SBOM? Well, as the word it says, it is basically a ledger, a document that describes what, in this case, the different ingredients are of a product or service. In the first place, we see it for security. So security bill of material in this case entails where there might be potential vulnerabilities or challenges in relation to a product or a piece of technology. Now, it's more than a document, because if you have a document and it's not that easy to work with, especially when it comes to vulnerabilities, you don't go and read throughout different documents to understand what those vulnerabilities of a specific product are, on the one hand side. On the other hand, technologies and products and services do change over time, and could also get upgrades and updates, and so therefore those documents might need to change. So, and this ledger is actually also a form of an electronic repository, which is being created in this case, or can be created manually if you are developing your own piece of software, or can be coming automated as a mechanism from an application security assessment tool, or other types of tools that can help developing those SBOMs. But more about that later on, because we will be diving into how to actually do the development of an SBOM together with my colleague Luca. And so what do we do with the IoT SBOM? We organize different types of activities to promote the use and the activities of the SBOMs, and also support, in this case, both development companies and users of technologies in order to get them to understand what SBOMs are all about. Next to this, we can also promote the support of these developments of SBOMs through the means of two major programs that we have running. One being called Digitalis, whereby we can actually support in Flanders companies that are thinking about engineering their SBOMs. So where we can actually offer some support and services in order to get those started, or through another program specifically oriented towards small technology companies, which are developing their own services, cloud services, or applications, and which is basically there to support, in this case, those technology companies in increasing their security posture or maturity, if you want. So this is basically to introduce what SBOMs are all about. Luca, you're somewhere nearby, so please help us out in getting a better understanding of how companies can, in this case, take the first steps in developing their SBOMs. We do know that there's quite a lot of developments happening in the world in terms of the SBOMs. There's some guidelines being written out on what minimum requirements of SBOMs have to be like. Also the exchange of SBOMs, but we'll be talking more about that in our next webinar. But there's also a number of companies that have developed some tools, and you'll be enlightening us a little bit about those tools, and then specifically what, in this case, Microsoft has been developing to that end. And in the next webinar, next month, we'll be deep diving a little bit further into those together, actually, also with the teams from Microsoft. Luca, the floor is yours.
Thank you, Ulrich. I think you have to allow me to share my screen. Okay, thank you. Yeah, there you go. Now you should be able to see my monitor. Good afternoon, everyone. My name is Luca Gattubiggio from ElSec. I'm an innovation manager here. Some of you might have seen my face at this point on webinars and other events related to other projects that we have as ElSec, and specific the cybersecurity AI project or the Cloco or Open Cloudification project. And today I'm here to showcase a bit what might be some interesting facts about tools, open source tools that are used to generate and manage SBOMs. In the specific, we're gonna have a look into GitHub and what they now provide as extra feature for free to generate your own SBOM. So what I'm gonna talk about today, well, a brief introduction will be given on what is an SBOM, but basically Ulrich already gave a nice explanation. So we're gonna look more on the behalf of our project on IoT SBOM and what might be some differences that you can spot while you're talking about IoT devices instead of generic SBOM. And we can also see how these two words are somehow connected. So general best practices can be taken from both words and they will still work no matter where's your field of interest. We're gonna talk quickly on why an SBOM might be useful, what are the advantages of using it, and trying to understand what are the needs and what are the ways to create a correct IoT SBOM or your SBOM in general. Also trying to validate a bit with some suggestions or recommendation on what are the steps to create and then validate your IoT SBOM. And finally, the reason why I'm talking today here, have a quick look on what GitHub offers as a tool for SBOMs and also some other open source tools that might be useful in that sense. So again, software bill of material or SBOM. As I said, we already presented what an SBOM is. If I have to put it in just one line, again, a list of software and components that are within your product. If you see the analogy with a supermarket, then it's the label that lists all the ingredients within the product that you're buying. In that sense, you'll try to put as much information as possible so your customers or your consumers will know exactly what's in it. And that means including dependencies, all the open source components that are usually not written by you, by someone else, but they're still included in your software, version strings, licenses, libraries, the software components name, you as an author that are providing the product, all of your suppliers and so on. And so what are the reasons that you would like to have, or you would think about while you would like to have an SBOM on your IoT device in this sense? And you can see how this extends from a generic software product or a generic product in which you have a standard SBOM. Well, you want to ensure that you have cybersecurity and you're maintaining correctly your industrial IoT device in this case. But you want also an easy way to provide something that is machine readable for the software, the firmware, the hardware in this case as well, all the products that are within your device in a way that you can export these and it can be easily consumed, not necessarily by people, but also by machines, because this introduces a lot of automation and validation processes that can be executed quickly. But you also want to help people. And in that sense, device manufacturers and users can also read the SBOM as a clear statement, a clear view of what's in your code or your product. Having an SBOM or an XIoT SBOM means that it can help you identifying and mitigate all the vulnerabilities that could come from components that are not even yours, but are included in your code as dependencies or are open source components. You can keep track and manage the software updates and the patches that are needed or that are being discovered by the use of SBOM and the supporting tools that help you with the identification of these vulnerabilities. And of course, in some specific sectors like the industrial will probably be, you have regulatory requirements and standards that you have to comply with, which means that sometimes an SBOM is even required. Which also means that you're providing something that will enhance the transparency and the trust that you can provide to your software or to your supply chain in general. So where do you start? Let's say that you already managed to create your SBOM. There are a lot of things to think about. First of all, as I said, you want to be compliant, and you want to have complete control over your processes, which means that all the standards, all the regulations, all the best practices that are in place for SBOM in general or for IoT devices that will need to generate an SBOM has to be there. A good example, and I will mention them, is the NTIA agency that defined a list of minimum elements that should be in any SBOM. You want complete and accurate information included in your software, which also means that you want to identify and describe everything that is within your software, within your dependencies, within your licenses, and all the potential vulnerabilities and all the patches that are needed for that. You want to be as much complete as possible. And of course, the data has to be secure then, and it's difficult because you don't have to keep track only on the moment that you generate the SBOM, but also at the moment that you're providing it to a customer, to someone else. So the transmission of the data, for example, has to be taken into account. That has to be secured. And of course, you're talking about the potential integration with tools that aren't directly controlled by you sometimes, or in general, that you can send it to different vendors or platforms, which also means that there has to be a system of compatibility and interoperability, as in standardization of formats and best practices or recommendations that everyone will agree with. But it's not only that, because, well, you know where to start, but then it's difficult to know where to stop. In the sense that in the specific use case, as the example of industrial IoT devices or processes in general, it's also difficult to identify where are the limits, because if you think about IoT edge devices, for example, then they're probably sitting on an edge layer, which is maybe connected directly to your sensors, to your actuators, and so on. And the communication will go through another layer, which is usually the fog layer, which is the local network, and will do some local processing there, and will handle the communication with what is the cloud layer, which is even another layer above that. So the question there might be, okay, but if I'm defining an SBOM for an IoT device, where would I stop? Like, should I include everything that is included in the edge layer? Should I stop in the communication within the fog layer? Should I include what the cloud is sending to my device? Should I include all the dependencies that are there? So you see that it's difficult in that sense to understand where to start and where to stop. And from a theoretical point of view, it might be easy. You can define some recommendations, some best practices. But then when you go to real IoT devices, you see how complex and diverse an environment can be from another one. So software components and dependencies are a challenge to be addressed. And in that sense, you can define some indications, some key points, like you will have to define the scope of your SBOM. So you can define what is the level of detail and the granularity that you want for your SBOM. The source from where you obtaining all this information has also to be trusted, but also define until what level you want to have this level of information. The format then to represent the SBOM is also important. We will see, I will briefly mention that there are several types of formats that are considered standard. And even if there's a way to translate from one format to another one, it's better to define it since the beginning, which format would you like to use. And then, as I said, the boundary is important. So you have to even define where to stop for your SBOM generation, especially when we're introducing the cloud, in which then the dimension could upscale quite quickly. So if you focus on the boundary decisions, then you can identify three main areas in which you would like to take your decision upon. The purpose, so who is the intended audience for your SBOM that might be relevant to define where to stop. The risk, so what are the potential vulnerabilities and the threats that are connected to the software components within your device, but also the dependencies and what comes from the connection of this device. And then, of course, the cost, because there are pretty clear trade-offs between how many things you want to include and how much further you have to investigate to making sure that everything is included in your SBOM. So let's say that you want to somehow validate your SBOM, and we're trying to give some steps that can help you with not with the best practices, but mostly on the recommendation side, like to take them as a guide that can help you validate your own specific use case, because of course each use case is on its own. So the main steps is, of course, as a very first step, you want to verify that everything is included in your SBOM. So all the software components that are used, and this includes firmware, operating system, the applications that are running, everything that is installed on the device, are included in your SBOM. And you want to make sure that everything is included, but also the metadata that it comes with it. So like name, the version, the location of the components, all the licenses and the vulnerabilities that might be included there. And once you have this, you want to compare it with your source code repository, for example, in which you technically have a full overview of what should be included in your SBOM. And you want to make sure that you included indeed everything. And as a fourth and last step for these main steps, you will have to review the product documentation and everything that is relevant in the specific use case, and you want to make sure that everything is in there. But then if you think about IoT devices, but again, this could be applied for all the generic SBOMs as well. You want to include third-party components. So if they're there, you probably want to list them and include all the licenses and all the dependencies that come from the third-party components. Considering that, since you're, in this case, talking about IoT devices, there might be additional security measures that could be included. An example is have specific secure communication protocols, specific encryption systems, or specific authentication systems that are maybe related to your IoT device, and you would like to have this included in your SBOM. And you want to ensure that the hardware components are also there, because so far I talked about software and firmware, but since we're talking of specific devices, hardware components might be included in your SBOM, like sensors, actuators, and any other device that is also attached to your IoT device. And as a very last step, then the review should be on a regular basis, like constantly update and check that everything is complete, it's accurate, and it's up to date, because your production, your products might constantly change, might be upgraded. Some software can be changed, especially now that we're in a world in which your software is constantly deployed and integrated in a sort of loop that never stops, and you constantly have a new version of your software. It's important to check on that as well and make sure that your SBOM reflects what is your latest version. So how do you generate then your SBOM? At this point, there are several solutions. We mostly focus on open source solutions, but yeah, the list is quite long. Here I'm listing some of the well-known tools, but there are plenty others. I'm gonna showcase a bit, for example, how dependency track work. This is mostly on the management side. So it's the post creation section. The GitHub SBOM tool is the main topic of today, but soon we're gonna talk about the Microsoft SBOM tool, for example. And together with them, there are plenty of others that are sometimes more specific on other subjects, like Sift or Trivi, that focus mostly on images, for example, or file systems. Here you can see an example of, in this case, dependency track, in which you keep track of your SBOM and the evolution of them, and you put them in a visual interface that can provide you insights on how to tackle some of the vulnerabilities that might be present, for example. But I'm gonna show it quickly live, how it is how it is used once you have an SBOM to upload it and check on it. And the same comes for these tools that are available. In this case, here the images are showing how Trivi checks on vulnerabilities that might be present in your container image. So using tools, using software component analysis and libraries are useful. They bring a lot of advantages. First of all, you think about automation, because in that sense, the constant generation of new SBOMs can be integrated in your CI/CD pipelines that will automate the process and will make everything connected to your production environments, for example, in which a new version will correspond, a new version of your product will correspond a new version of your SBOM. You want to make sure that, again, your SBOMs are complete and accurate, which means that if you have tool specific for that, you will probably reduce, especially the human error that can be a factor there. And as a consequence, you will reduce the risks. And that will help you with the analysis and the management, because you're using tools that are specifically made for that. So you have a better visibility and a better control over all the software components, all the dependencies that are there at the beginning. And without an SBOM, you might not even be aware of some of the components and the dependencies that are there inherited by your code, for example, especially talking about open source solutions. And again, reflecting what was described in some of the previous slides, you want to support compliance and all the regulations. So if you're using a standardized format to have your SBOM, like it is the SPDX or the Cyclone DX, you're making sure also that your customers or other entities will be able to consume your SBOM and check the validity of your product. Plus, these tools usually offer extra functionalities, extra or additional components that you can integrate, for example, the VEX format. There are challenges that comes with the use of extra tools, extra libraries, extra frameworks. In this case, as I briefly already mentioned, sometimes it's difficult to choose the right standard because there isn't only one. The two main ones are the SPDX and the Cyclone DX. So even if there are tools available, and I will also show it to you how to do the translation soon, there's still the possibility that something gets lost in the process because they're two different formats. And most of the tools that are available right now, especially the open source tools, have this new feature of translation as something that is still a work in progress feature. So you always have a bit of a risk that something might get lost or not properly translated. Therefore, it is important to make sure that you're using the right data format for your SBOM. You want to make sure, that everything is accurate and complete, as I said already. When you're talking about complex software products, it's difficult to find an end for all the dependencies and the components. And even if you're using tools, then you have to make sure that everything is included in it. Security and privacy, of course, are part of the SBOM generation. In that sense, the SBOM is something that you want to provide as an added value. But at the same time, it's something that contains everything within your software. So you want to make sure that the regulations are respected and you don't want anyone to get access if they shouldn't. And at the same time that they could modify your SBOM for malicious intentions, for example. So a good way, but it's also a challenge, is to integrate the SBOM on your development lifecycle. As I said, you can use them to integrate it in your CI/CD pipelines, which is on the theoretical aspect perfect because you will have the automation and all the benefits, but it's still something that has to be done in the first instance. And it's sometimes might be challenging or difficult. And then, the SBOM will show all the vulnerabilities that are present in your code or in your software or in your product, which means that then you have to handle those vulnerabilities and identify them and trying to mitigate all the risks that are coming from those. Okay, so the main core of today's presentation is about GitHub. And this is because recently, as in March of this year, GitHub announced in the blog that they host that they offer this extra functionality as an SBOM tool or as an SBOM exporter. And as they mentioned it, they said that they were following this creation followed by the US executive order that in the United States now stated how an SBOM has to be a part of the offers that you have to provide, especially in specific sectors. So from the GitHub side, they tried to find an easy way to generate a share an SBOM, and therefore they developed this extra functionality, which is pretty straightforward, and I'm gonna show you how to use it. What they will provide is an SBOM that is already in SPDX format, especially if you use the UI of GitHub, and is NTIA compliant. So what does it mean, NTIA compliant? So the agency, the NTIA, which is the National Telecommunication and Information Administration Agency, defined this as a document that contains the minimum elements that an SBOM should contain. This document has been published in July 2021. And so they stated that if you're generating an SBOM, the 7 components that you can read in this list, so the name of supplier, as the organization that created or is providing the specific component, the name of component itself, so like the file name or the package, the version of the component, the unique identifier that is there, like the NIST CPE identifier, for example, the relationship that are within your components. So the dependency relationship should be stated, the license under which some software or components might be distributed, and the date of the SBOM when the SBOM was physically created. All these components should be included and form the minimum elements that should be available there. And then, of course, they're also encouraging the use of machine-readable formats. And in this case, again, SPDX and CycloneDX are the main ones. So how do you export your SBOM, or any SBOM actually, that is available on GitHub? So what you can do basically is go on the GitHub page of any software that you as user have read access. And if you go to Insights, then there's a button in the dependency graph that allows you to export the SBOM. It's also easier if I share with you an example. So in this case, you should be able to see my monitor. I'm on the GitHub SBOM CLI extension. Then I'm gonna talk about also what this means. This is the main page, like the description and the README and all the code that is there. So if you go to Insights, you will see that from the list of options that you can choose, you have the dependency graph. The dependency graph shows what are all the dependencies that are connected to your code. And at the same time, you can see the list of all the software that is dependent on yours. In this case, this specific CLI doesn't have any dependent. And on the top right, you see the button Export SBOM. So basically, it's just a click, and it will automatically download an SBOM in a JSON file, which is an export in SPDX format, which is something similar to what I'm showing here, but I'm afraid you cannot see it immediately. There you go. So this is the example of the SBOM that I'm downloading it. I tried to rearrange it a bit because being machine readable means that without any indentation, it's just one long line. And you can see that downloading it shows who's the creator and when it has been created. So following the NTIA compliance format, the name of the tool, the potential licenses that are there, and then the list of all the packages. And if you scroll down, I just highlighted one of them, you will see that there are also defined all the dependencies that could happen between a specific element, a specific component, and another one included in your code. So this is the example of SBOM that you can basically retrieve for free from the tool. Now, GitHub didn't stop here. Like, this is the easiest way to get your SBOM. And as I said, you basically can go to any repository that you have access to, read access to it, and you can download the SBOM, which means that it's not even the company or the owner of the code that really needs to provide the SBOM. Of course, they can add some customized option, and they can improve or change some of the options there. but everyone is allowed to get access to it. And what else do they offer together with that? Well, at the same time, instead of downloading and exporting it, you can do the opposite. So you can, if you already have your SBOM, you can upload it on the dependency graph. And in that sense, it will the opposite will appear. So you will create the dependency graph starting from the SBOM, which also allows you to use Dependabot. I'm gonna quickly also mention what Dependabot is in the next slide. But like briefly, it gives you notification when something is happening on your SBOM. Then you have an SBOM GitHub CLI extension. In this case, what it does is it provides something, some extra functionalities to the just export function. For example, you can ask, instead of only using SPDX, you can ask for the CycloneDX format and have the inclusion of licenses. But again, I'm gonna quickly show how it works. They have REST API now. At the beginning was announced, but now they're available. Some of the REST APIs are still on the beta versions or in experimental versions. But you have, for example, a REST API that you can contact to export your SBOM. I'm going to show that as well. And then the integration with GitHub actions and third-party tools that might be used there. So I said dependency graph and Dependabot. In this sense, GitHub provides this option of uploading your existing SBOM. So let's say you have already generated, for any reason, your SBOM, and you want to upload it to GitHub, then it will generate the dependency graph, which is useful if you don't want to, have the software already there or all the dependencies already there, so you can have it, for example, private. And once it's generated, then you can enable Dependabot for all the vulnerabilities that are there. So Dependabot is a free feature that is available for everyone that has an account in GitHub, on GitHub. And it automatically suggests and updates the dependencies on your repositories, which means that you can, your dependencies will be up to date and patched against all the security vulnerabilities that might appear at any moment. It basically scans your repositories for the dependencies and then compares them to the up-to-date security vulnerabilities. And when it finds one, what it does is create a new pull request with the suggestion on the type of update that you might do to the specific dependency. And then it's, in any case, it's you that decide whether to review. So you will review the pull request and then decide whether or not to merge it. So it's quite useful. And in this sense, it's still on the dependency graph. I didn't show it because this was another library, but that's for your repositories. You have the extra option as a potential options that you can click and enable Dependabot for free. But I also said that there's a GitHub CLI extension for the GitHub CLI, in this case, specifically made for the SBOM. And it's just one single line of command, which is the one that I'm showing here. So it's an extension installed basically on your GitHub CLI, which means, of course, that you have to have the GitHub CLI already installed on your device. But again, it's another extra line of code to do that. And then you have first to authenticate as a user, otherwise you cannot use it. What it does is provide some extra functionalities. Like, for example, you can ask for the CycloneDX format. I can quickly show you that if you write SBOM, as you see, it's an extension that has not that many functionalities. But for example, in this case, with the -c option, you can ask for an SBOM, for a CycloneDX SBOM format. Otherwise, you will get the standard SPDX, and then to include the licenses for the CycloneDX format. Otherwise, it comes automatically. And you can ask for, you can query for any repository that is reachable. For example, if I ask for the same one that I've been using for this example, which is actually the extension itself, which is stored in GitHub, then you send the request and you will obtain the SBOM that you can then write instead of output it here in the console. Okay. To continue here, another thing that I mentioned is the REST API. It's actually REST APIs because there are several available. Here's the example on how to use it. This is an example that shows, and it comes from the official documentation on how you export an SBOM for a repository. And in this case, it gives you indication whether you're using the GitHub CLI as it's showing, but also if you're writing a JavaScript or C URL. So there are different ways to interact, and there are specific APIs, but as I said, some of them are still on the experimental phase, so I wouldn't delve too much into it. But it's something that they're working on. They're already been working on for quite some time, so there's something extremely useful for sure. And then as the last part, GitHub Actions and the third-party integrations. As on the right side, you see here, and it's again from GitHub itself, that they provide an example of actions. If someone is familiar with GitHub Actions, it's the automation, the CI/CD pipeline integration, let's say, commands that you can use to automate as much as possible the development of your or the life cycle of your code. So this is the action that is provided by GitHub itself to show how to publish an SBOM as an artifact in your workflow run. And in this sense, then once the action is completed and you go back to your page with the code, you will see that in the artifact section, you will have the SBOM automatically generated every time that, for example, you have a new version of your code. So this brings the integration with your CI/CD pipelines, the automation part, but also helps you keeping up with the latest version of the SBOM and all the consequences, like you have something ready to be exported immediately as a valid product. And this could be an input for the external tools that you might use for compliance, for validation, but also for management, for example. Because speaking of management, for example, and a very well-known at this point open source tool is Dependency Track, which is a software composition analysis or component analysis. It's a platform, and it helps you with the management of the SBOM. So it ingests SBOM as a input, and what it provides is the analysis and the continuous monitoring of the SBOMs over the different versions, for example, and it evaluates potential vulnerabilities and checks on the licenses and the versions and checks that your software is up to date and so on, and then provides insights, for example, or an output that can be used somewhere else. This is the example that they provide, again, on the GitHub page of the tool. So you see that what you can get is, in this case, only CycloneDX, but at least for the moment, CycloneDX format SBOMs. And then based on vulnerability software, intelligence softwares that provide all the insights on potential vulnerabilities and all the repositories of the different, for example, programming languages or software packages, you will analyze your SBOM and you will find your vulnerabilities, for example, and then you can provide notification for the users or the developers, integrations with your APIs, or vulnerability aggregation. So it depending on what's your use for it. I mean, it could be easily the three of them. But in a nutshell, let's say the dependency track is used to first identify the known vulnerabilities that you might have by scanning your software dependencies and looking for all the known vulnerabilities. You will track the origin of your software dependencies. You can comply with the regulations and the policies that you can also customize on the tool, and you can potentially automate the workflow with the integration in CI/CD pipelines. In that sense, I can quickly show you how it works. And in this case, as I said, we cannot use the SBOM that we downloaded, for example, on GitHub, because this is in SPDX format. So what I did is use another tool, another open source tool that is called Sift, and it's a quite famous, one of the most famous open source tools for the creation, generation of SBOMs. As an extra functionality, it provides the translation between SPDX and CycloneDX. So I'm not going to show you the process. It's, again, once you installed it, it's basically one command line that says, take this SBOM, translate it from, in this case, SPDX to CycloneDX. But since it's an experimental or a beta feature, again, there might be potential issues, as there are some risks, like not necessarily everything might be correctly translated, something might be changed, and so on. So what we do is take the SBOM.dx, and now I'm going to show you the tool itself, if I can, because okay, this is so this is the main page of dependency track. If you're curious to know more about it, dependencytrack.org is an open source tool. The installation comes mostly on containers. In this case, the main usage for a quick start in this example is just Docker Compose or Docker Swarm, or if you prefer, a manual execution. So it's just a pool, a creation for the volume, because you want the data to be stored outside the container, and then it's just a Docker run, basically. As you can see, maybe something that is worth it to mention, it's quite resource intensive because, yeah, it requires, I think the minimum requirements is for 4 gigabytes of RAM. So in general, it's a tool that might require for some resources, which is the reason why, for example, I'm not hosting it directly on my machine, that my laptop couldn't handle it, but so it's running on a AWS virtual machine in this case, but this is just an example. So what you have it in this case is a product that is mostly used not for production environments, because in that sense you will probably look for something more complete as a development that entails the use of Kubernetes or some redundancy and so on. But this is like a container that has everything built in that you can use, for example, as a test or a live demo example as today. So what you have is the dashboard here, in which it shows you all the potential projects that you have with all the risks associated, the components that might be vulnerable, all the risk score, and provides a risk score for that. And when you go to the project, in this case, I only have 2 projects that are basically the same, just showing that I can also use and provide different versions of the same project. And then you check on it. And from the components, what you can do is upload your SBOM. which has to be at this stage, as I said, an cyclone.dx format. And automatically, what it will do is it will provide the vulnerabilities that might be present. So if you check on the components, this is the list of the components that we're seeing with the SBOM exported from the actual CLI extension that I just showed you before. And you see here that some of the components, in this case, for example, has been checked and they're on the latest version. And then there might be some component that they have a major risk because it's not up to date. And if you check on the vulnerabilities, this is a very small example just to give you an idea on how the software works. But in this case, it has been identified a vulnerability that is present in one of the components, which is the Golang component. And this is the severity of the component, what type of vulnerability you have. If you click, it shows you what it is and where it comes from. And it gives you from where it has been analyzed and usually shows you where and how you can fix it. This is a prediction of the exploitation. You can put policies. So if I show you how this section works, you have the list of vulnerabilities that are basically constantly updated. These ones are all dated from yesterday. You can put licenses on there. You can add your own licenses. You can add your own vulnerabilities. You can set up your own policies for that. And as you can see in the configurations, you can set up where the vulnerability sources are coming from. So in this case, it's using the NVD, the database, and GitHub advisories, and then all the repositories from all the different programming languages, for example. Okay, back to the presentation. Okay. So some last reminders. This GitHub SBOM exporter is quite new. Now it's been, okay, GitHub itself has been working on it for, I think, a couple of years. So now they published it and they made it available to the public since March of this year, but it's still a work in progress solution, which means that being under development, that might some bugs or limitation might incur at any moment on a newer version, even if GitHub has the potential to make sure that everything is correctly, especially when they're releasing a new version. And at the moment, if you think about the exporter itself, it's of course only available within GitHub. So for your repositories, it might be perfect, like it might be enough. But if you think about, for example, other open source tools that are available and are more specific to other sections, like even if you're putting your images, your container images, which is something quite used nowadays, you might not have a full SBOM of that, so you might need to rely on open source tools. And the examples that I gave are Trivi, for example, that is mainly used for images, or Thift, that it then has been used in combination with Gripe, so you can have the analysis of your image, container image, whatever it is, and then with Gripe you can check on the vulnerabilities. Just as a quick extra, I can show, for example, that if you want to check on the, oh wait, I need to share the terminal first. You use Thift, and then you provide an image, let's say, and Nginx, the latest version. it will automatically check for that, parse the image, and do the scan. And then it will also give you the example of, in this case, the dependencies. If you use Trivi to do the same, let me clear. If you use Trivi and you ask for the image, the same, and Jinx, the latest version, it will again download it from the repository and then do the analysis. And well, maybe the terminal is a bit too little to have everything in one line, but as you can see, all the vulnerabilities are here present with the level of severity and what are the potential solution or issues that has been connected to the specific vulnerability. So as I said, it's mainly and only at this point for GitHub repositories. And yeah, if you're using the exported as a free version, as a exported in the UI section, then it's just SPDX format. But we also saw that you can do that for CycloneDX formats if you use the extension, even though it's an experimental feature. So to conclude and to wrap up here, the SBOM tool for GitHub provides something that is quite easy to use. Like, it's a very simple tool that you will use to generate your SBOM. And it's basically available for any type of repository that is there, regardless of the size of the complexity of the project. In this sense, what you might still consider is the fact that you have something NTIA compliant. This is true. So you have the minimum list of elements that you would like to include in your SBOM, but maybe this is not enough for the level of granularity that you would like to have. But in any case, it's a perfect starting point because you can see from your repository what are the minimum requirement. So it's a perfect starting point that you can build up starting from there. So if the tool itself is missing some of the components that you would like to include and you're sure that they're there, then basically you can add them there and start from that one. And also it doesn't require a lot of knowledge, or you don't have to develop your own code that tells you that to generate your SBOM. You don't have to add anything additional. You don't have to install open source or paid solutions to do that. It's basically already present and available for everyone. Another advantage would be the scalability, mostly the flexibility, because this integration will be included in your CI/CD pipelines. So you generate SBOM when you're talking again of large and complex project, but also several projects all together at the same time, because basically you're automating the process, which means that you have mostly just check on the correctness of your final results. The reliability is another important aspect because, yeah, we're talking about something that has been tested already by some organization, but it's developed and updated by GitHub, which has quite a great number of, it has a huge community behind that can also help with the development and the process of update of their version. And of course, the compliance aspect. So you're generating an SBOM that might comply with the regulations and the formats that you might need. Okay, this was my last slide. Hope it gave you some sort of introduction to, in one sense, on one hand, what an SBOM is needed and why you would need it. On the other hand, some more practical examples. Those are mostly introduction to show you how to use some of the open source tools that are available, how to interact with them on the command line, and mostly how GitHub did that and made it available for basically free in their website, in their repositories. I'm aware that I didn't show that much, but you can see that as an example. So an introduction to different tools, you get an idea, and if you're interested, of course, in the first instance, you can check by yourself, because what we most of the time show are open source solutions. So they're available. There's usually a user base that it's there, and it helps you with all the more detailed part or the more complicated part. And on the other hand, we're happy to help if you're interested in anything specific. Then we can take it further and maybe have another presentation or another introduction to specific solutions. So I hope this gave you the idea. And if there are no questions, I think my presentation ends here.